We are privileged here to have Dr. Chandrashekhar, who is the Chief Architect of the Ministry of Health, and he's going to talk about modern trends in planning and designing hospitals. And I would say that this is an important aspect where we guys would be able to get a peek into many other areas that he could touch upon while he moves around in the government circles of what's really going on and what the thought process looks like for the future. Over to Dr. Chandrashekhar.
Good afternoon, everybody. In fact, here most of the people who are from the clinical side but I don't think there must be any architect. Is by any chance, oh, there are two architects. Very good, that's nice. I always keep sensitizing people, telling that medical architecture is something different than the regular architecture, because he has to synergize various activities. Like people say, the architect, when I asked the architect, why did you design like this? He said, the doctor said so. So that was the clinician's angle. Similarly, there can be a nursing angle, there can be hospital administrator's angle, there is a patient's angle, there is a visitor's angle, and the public health engineer's angle. I always give an example, just location of the sluice room, where the bed pans are cleared. Nursing station, people say, let it be closer to that. The service engineer says it should be near the toilet so that I can club the disposal pipe. Administrator says that what is the walking distance. So such issues come in every planning aspect, and that is where we say synergizing is the specialized field where the medical architect works. Now I will be quickly taking you through some of the important aspects. Like we say, good architecture is much more encompassing than outward appearance. Generally we say, how's the beautiful elevation, wonderful structure, but functionally is it worthwhile as a hospital? A lot of people compare hospital with hospitality, that is hotel industry. It's not so that easy. In terms of planning they may say, but there are. It is the result of a team effort yielding good building design through a process of problem solving and innovative thinking. To create a well-designed therapeutic and diagnostic environment that supports efficient delivery of healthcare services, a robust, cost-efficient, friendly and comfortable environment for patient faculty. Generally, the hospital projects are two types in nature. First is the brownfield, where you are doing refurbishment or remodeling of the project, and it is also in the big way. People ask me, how do you differ from a government hospital to a private hospital in terms of area, requirement, etc.? I said, there is not much of a difference. Divide the hospital in three basic parameters. First, OPD, where the doctor or clinician is stationary and the patient is mobile. IPD, where patient is stationary and doctors and other equipments are mobile. And third is the diagnostic or the procedure area, where the equipment is stationary and patient and the clinicians are mobile. When you do these kind of a division, it becomes much easier for you. Then you have to think where you want to have a patient focused care, what all services you want to bring in. Things can be worked out, space parameter can be worked out. When in a brownfield hospital, what you try to do is, old hospital, you want to have a renovation done so that the efficiency of the hospital improves. When you compare in terms of space parameter, the government hospital has a major area spread out in waiting area of the OPD, and in a private segment, people can come only by appointment, so you require lesser area and more consultant room. But technical area like diagnostic and other thing being equipment oriented remains the constant. But the inpatient area has also a difference. There you have a single and twin sharing room. Here a 6-bedded and 8-bedded wards. So that is how the area gets almost the same. It doesn't make any difference. Similarly, when I talk in terms of finances, focus is patient turnover. In a government, queue length. The waiting period 1 month, 2 months, 3 months depending upon the procedure. And in the private segment, the patient turnover is in terms of money. How quickly I can recoup what I have invested. Major crunch, we all felt faculty or the experts are in real short supply. In Government of India, under PMSSY, we call it Pradhan Mantri Swasthya Suraksha Yojana, in which we are setting up 6 AIIMS-like institutions, and construction is in full swing, and most probably the college should be on by the next session. That is the target. These are at the 6 places: Rishikesh, Bhopal, Patna, Bhubaneswar, Raipur, and Bhubaneswar, Raipur, Patna, Bhopal, Jodhpur. So these are 6 places. Now, where will I get the faculty from? Rightly checked up in the earlier speakers and this thing, we thought, let us start the second phase. Pick up those old renowned medical colleges of the state government, upgrade them, have more PG seats, set up a super speciality block, trauma center, whatever is the need of the hour, increase the PG seats. Those people may be the future faculty for us. This is how the whole system works. Then we thought, okay, as a state, you know, that health being a state subject, they don't have enough budget. So we pumped in 150 crores each to all these institutions, upgrade them in terms of medical equipment or infrastructure as the case may be, and we have taken the promise from the state government to act on recruiting faculty accordingly. Such things are happening, but still everybody knows it's a tough time. Even a person, a doctor, he gets a difficult time to choose between a private institution and this thing based on his financial limitation. So putting all together, I thought in this forum I can sensitize you certain important planning aspect in terms of planning parameter. Then I always say care versus cure, just one letter, it makes all the difference, which is we call it evidence-based design or a healing architecture. Most importantly, sensitizing you on indoor air quality, and lastly on safety factor. These are the way I'll be presenting myself in this presentation. And greenfield projects, you know, it's all fresh new projects. So hospital location is very important. We have seen number of problems, whether it is earthquake prone, volcanic eruption, landslides, tsunamis or hurricanes, flooding. Now this is one typical example of Dhaka Apollo, where that area was prone to flooding, and the plinth level is the first level where every hospital has to set up. There they have to see, make sure that when there is a flooding, at least your hospital is safe enough from this. So this is how it looks like in a routine way. Master planning strategy is very important. Do any kind of a planning, first think overall. You may have less finances. Do your construction in phase, but do the planning. I always say, Aruvilo was master planned way back and construction is still going on in Pondicherry. So every design should have a planned zones for future growth. These can appear as a dotted line on the site plan or may be developed as constructed but unoccupied shell space or as a structural capacity to allow for future vertical addition to a building. Now this is a typical site. This is the site of Jodhpur, where presently the AIIMS like institution is being considered. In this, when the site was given, we thought divide them into 2, institutional and residential. In institutional, you have a hospital, you have an academics, that is medical college, you have services like substation, electric, AC plant, etc., and a green buffer between the residential and the academic zone. This is the site of Bhopal. Here you can see the modular, all these are future development. If you see the lighter one, these are all how it will grow, because we have learned that in present age there is no space to grow, and when a hospital gets popular, it's very difficult to shift the location. So it has to be well planned to an extent that how futuristic it can take load of. Now here you can see this is the hospital zone, this is the trauma center, This is the services. We also have Indian system of medicine. So Ayush and herbal gardens have been taken into that. Then medical college, nursing college, the auditorium and the future dental college, and the hostels or nursing, college students hostel. We also think of site circulation, because every now and then you will not be in a position to take different entries for emergency, public entry, main vehicular entry, residential area entry. These are the things which we make. When we come from a master planning, we come to a micro zoning. That is, now this is a live example. We have built out of those upgradation one of the institution called Nizam Institute of Medical Science in Hyderabad. We built around 350 or odd bedded super specialty and 150 bedded trauma center. Now what we could do, you could see any teaching hospital, the travel distance is also very important. People waste time when you say suddenly somebody is needed in the inpatient. He says, Doctor Saab kahan hai? He is in OPD. OPD kahan hai? Half a kilometer away, I don't know how long. And he cannot be called. So it's better to utilize such super specialities within the same level. What we do, you have anything for replacement here? Excuse me. It's not working. What we do is OPD, IPD and teaching facility of the same thing is on the similar level. You can have, okay, you can have a clear-cut defining cardiac surgery, cardiology, neurosurgery, neurology, nephrology, urology. You can make each floor in a level so that patient can be taken to the precise, these are all referral, so they can straight away reach. And also trauma and super specialty is connected, because once the trauma patient stabilizes, he has to be shifted to some of the specialty, so you can have the connectivity. So these kind of a micro zoning is also important. Connectivity also can be possibly from 2-3 point of view. First, you may have a common facility like diagnostic facility, CT, MRI, etc. You cannot duplicate. These can be utilized by both of them. Similarly, the theatres are on both the side, and cleaning sterile corridor can have the connectivity. And lastly, you can also have some of the facilities like wards which they can shift. So this is how you can carry on with the micro zoning. Now, is it working? Now here you will find this is the teaching department of neurology or neurosurgery. This is the OPD of neurology and neurosurgery. And this is the wards of neurology or neurosurgery. And then we have the vertical core where to have the connectivity. Now when we do different specialty, we try to club in operation theatres and ICU and SDU at one level, for the reason they are heavy service intensive and also as a staff problem, because we don't have that much of manpower. The similar level difference can be handled by floor wise theatre above theatre in a vertical stack also. But once I was trying to explain these things, one anesthetist came running. Sir, please don't do, I have to do all up and down. It's better be in the same level. So there are a lot of parameters in terms of manpower related to that. When it is related with any of the private institution, it costs. And in the government institution, that much manpower availability is a problem. So it has a support services. This is how we work out a stack diagram. In the stack diagram, you have different services put together, different specialities in different zone, and you can see the connectivity at 3 levels. First level of connectivity you can have where the people can utilize the diagnostic facility. And second level of connectivity where the theatre to theatre, and that floor can be even higher than routine one, it doesn't matter, but all the services can be handled. And the top floor can be ward to ward. what kind of designs people expect, because hospital is a continuous incremental process. You have a loose fit design. The concept of loose fit is to design with a larger spaces that can be used for more than minimum function originally proposed, and to arrange them in departments or grouping that allows for future. Nowadays you must have seen pre-stressed and post-tension slabs are there. You have a column free space. You put drywall partition. Tomorrow there is a need changes, you can always very easily redo the whole thing. Adaptable flexibility. Spaces can be designed to adapt to multiple uses. An example is patient room that can be adapted for purpose of simple procedures such as a line insertion. The different function can be accommodated by simply adapting the space because it has been planned to serve a range of possibilities. Convertible flexibility. Another type of flexibility is when the relatively low effort, time and cost, a space can be converted to another use. A patient room with plumbing, gases, electrical system in the wall for future conversion to critical care. Because at the time of construction, some of the activities can be handled, it will not cost much. But later on if you have to do it, is much difficult. Robust utilities. In order to offer flexibility in design, the utility and communication infrastructure of healthcare facilities should be capable of expansion and upgradation. Availability of utility and network capacity simplifies, dramatically reduces the cost of the future project. Now recent method are plug and play. Just as all the utilities of the cities are uninterrupted when one property undergoes a construction or demolition project, a hospital should be designed so that the utility and primary horizontal and vertical circulation infrastructure remains in service while departments, wings or entire building are added or removed. The latest methods, what we call this, is pre-engineered structure. In this you can have a different model. You can have a courtyard fills, which you can see it here, that you can create and just fit in, wrap around. Some of the department needs expansion, you can put those pre-engineered structure on gantries or even over the roof. You can without overloading the actually existing slab. And this is what we call it plug and play. So existing hospital, you will be in a better position to do these kind of changes. Now one more, using technology all the time, even in the morning it was spelled out, even in the construction, building information modeling is very important. It expands benefits to hospital design and operation, improves better design coordination. This is so service intensive so that coordination becomes a big issue. Generally the hospital project becomes expensive and time overrun takes place. And systematically assemble structured information about the health facility for project manager for planning to commissioning and maintenance. Saves time in project implementation and avoid error. Now in the health ministry we have taken one more specific order. That is, at least we have started with us, that is government and public sector undertaking. All the buildings in healthcare nowadays are inbuilt with 5-year maintenance in the tender stage. Invariably failure of the wonderful hospital happens because of the maintenance. Like we say, it's very easy to make friends but very difficult to maintain friendship. Same way is the building. Any wonderful consultant will come, beautiful materials are put, everything is in use, but things are not maintained, it becomes a big issue. In government we face the problem of coordination in terms of mainly infrastructure, equipment. If infrastructure is ready, equipment has not arrived. If equipment has arrived, the trained manpower is not there, and end of the day we find the failure happens. By the time he says my defect liability period is over, someone says my warranty period is over, and the client is in a real distress. He says I haven't opened the package and I cannot work because I need again money for maintenance. So creation of maintenance budget, and at the time of very initial stage it becomes a binding to the contractor or any supplier that he is not going away for another 5 years. That means he better do his job better. Then design guidance. Nowadays the green building parameters are there. Compact planning, reduce travel distance, people and services, which I just explained, increase efficiency, better control, placement of services with respect to main usable area, ease of future expansion. Then segregation of movement of vehicular and pedestrian traffic, which is very, very important in any of the hospital planning. Free, safe movement to large pedestrian volume. Somebody came and said, sir, they had come from abroad and they said that we want to use, tell you the wonderful flooring which we have brought in. I said, okay, I'll allow you to make a presentation around 2 o'clock. But my request is kindly visit my institution around 9:30, 10 and come back. He said, fine. We put him onto the AIMS. 1 o'clock he was changing his presentation. He said, sorry sir, for this crowd my floor will not work. We have such a volume and that volume has to be handled both ways. So similarly, whether it is a private, people come with the computerization. Someone hurriedly implemented that computerization into our OPD system in AIMS without realizing the total crowd. He said, like airlines or railway, you pick up the token, wait for this thing, the OPD they will announce. 3,500 people were grabbing in the token counter. We are now thinking, like he said, Dr. Praneeth said in the morning, the problem is 24/7 call center, these are the issues we are making, but we have to make sure everything works. It takes little time, but we are also working on the similar pattern. Like if my appointment is going to be at 12 o'clock, why should I crowd around at 9 o'clock or create problem for parking also and create, frankly speaking, number of us would like to visit AIMS and get themselves treated there. But we say, oh, it's so crowded, let me go to Escorts or Wokhard or Apollo or some other place. That is why we are saying that when we want to strengthen the government system, these technologies have to be brought in. Public-private partnership is the answer that even Planning Commission has realized. First such example we demonstrated by doing sports injury center. Any of you which you have seen, otherwise you can always visit and see. There we have done the PPP model, the total diagnostic system outsourced. Space is given. It's wet leasing what we call. We take some share and you take your share. Put up your equipment, run for us. What you require is a space and what you require patient, both we can give you in the blind spot. There are certain toothing problem, but people are out with that. Entire lab is outsourced. Operation theatre for 5 years along with medical gases, maintenances with the same agency was executed. So these experiments have been seen. Then we also want anybody stepping in and say, oh, is this the government hospital? That kind of a feel. It is not only the look, but the services, all has to be integrated, and there we put a facility manager who takes care of all your maintenance aspect rather than doctor attending to all the problem. Let doctor do the clinical job. Then modular design, people don't like to construct something in future on the upper floor. Do a modular kind of design so that a building, when it is complete, is in full functional. Some of the design guidance is energy efficiency, focus on conservation through features, inherent design, north-south orientation, main patient areas to control the heat gain, courtyard planning and environmental consciousness. These are very key issues. First thing what we did, we tried all our AIMS design, run a design chariot. Terry, that is Tata Energy Research Institute, was the consultant for us. We paid the money, made sure that all these buildings are green. Then we brought in regulation. All government building without 3-star Griha rating, the building will not be sanctioned. The reason is only compulsion works, recommendation doesn't work. We, in place of like accreditation, we also try to do, if you want to be in a CGHS panel in the hospital, are you accredited? So putting the things in compulsion mode, things work. Like they say, even in Singapore everything works. One Singaporean presenter came here in a conference and mentioned, which all you know, Singapore is a fine city. If you spit, $200 fine. If you throw garbage, 300 fine. So that is a fine city. So it is out of compulsion. Abroad, when little late, you run to the parking, make sure that you put the money or the coin because you know you will be challan. Compulsion works and then people become very, very disciplined. Now, principle to guide the design of the hospital of the future, incorporate evidence-based design. That's what I said. Care and cure. Just one letter makes all the difference. Principle that improve patient safety, including single room, decentralized nursing station and noise reducing material in hospital construction. Infection control can be well achieved in a single room, but in government, I can't afford to have every single room. So we have devised some more solution also. Address high level priorities such as infection control and emergency preparedness in hospital design and construction, and use of antimicrobial copper in touch surfaces. We have started using all the hardwares which are touch surfaces, whether it is a door handle, IV fluid stand or the bed railing or the grab bar in the toilet, make it touch surfaces with antimicrobial copper. Copper alloy with 60% has its own killing capacity of this bacterial thing, rest of the thing will not. Question: if I use copper, first question came in, oh, it has its problem of this, copper sulfate, it is poisonous. Said no, we are using alloy. Second, we don't want to do a melamine finish on that so that it loses its property. Third, we say only touch surfaces. That means if I make a handle full of copper, possibility it can be stolen, it can be resourced. We are making a stainless steel, but only the touch surface. You don't use the whole handle. So only touch surfaces are made copper. This is the way we sat down with the industrial partner, and major players have started manufacturing that, and we have started utilizing as a first this thing. We are setting up 4 metro blood bank in all the 4 metro cities by National AIDS Control Program. We said start using here. One by one people have started picking up. Infection control has a major the thing. We can only talk about environmental parameter. Administrative control like hand washing etc. will be taken care by the administrators. But as a designer, I should specify something which helps. So antimicrobial copper has played a major role in that. What is evidence-based design? Evidence-based healthcare architecture creates safe and therapeutic environment for patient care and encourages family involvement. It promotes efficient staff performance and it is restorative for workers under stress. Designed to give patient, visitor, staff connect with nature. Remember, we all come from nature and nature is a great healer and nature are known to be therapeutic. Then daylighting, natural light to reduce stress, improve patient. Natural light improves health outcome in the form of depression, agitation, sleep, rest activities, rhythm of the body. Poor lighting also contribute medication error. That's why we say don't only staff focus, patient focus, even the staff focus. Maximum errors takes place in nursing duty station where due to poor lighting. Now this is I am trying to demonstrate one of the small ward designs in which this is also we are practicing in Bhubaneswar design. Here what we have done, this is a total one module which meets the requirement of your MCI. It can take one specialization and it can work on natural ventilation and it can work on central air conditioning also. I will just take you, there are these are the courtyards and regular as per the norms. As a teaching hospital you need a conference and other seminar rooms etc. If you see in a little bigger picture, this is the ward. It is open and single bed also, but at the same time it is not single because of patient this thing. You can see a nurse's duty station which can handle one kind of a specialty or other kind of a specialty, depends upon the need. It can have, because of the courtyard and the windows caved in here, he can have the cross ventilation also in case it is not centrally air conditioned. And most importantly, the patient, his head is near the window, he is connecting with the nature. If you must have all received those email which is very popularly circulating, where the hospital, one of the patient always who is closer to the window, keeps describing about how wonderful weather is and today is sunny or rainbow etc. And one day the patient dies, everyone wants to occupy that bed. When someone occupies, then he sees there is a dead wall in front of the glass and the patient who died was a blind. That means just by explaining everything, the morale of all the patients were kept so high. So that is how the importance of natural light, that is why we all are promoting that green building parameter. Now this is how that will look like. This particular room, when it is cordoned off, you can have a single kind of a feel. You can have a companion, sometimes don't want to be alone. So you can have same way the one nursing station from both the side, and with the minimum staff you can handle and see the patient. So infection control parameter in terms of individual room, we try to strike a balance here. And evidence-based design, you are trying to bring in some of the features so that, like even in a pediatric hospital, we have seen long back, the whole wall etc. has been painted with Mickey Mouse, Donald Duck. The fellow comes for X-ray, he says this is like taking a picture, and the child coolly attends to the thing. Same way when we go to our general hospital, somebody is holding the leg and the child is crying, and these kind of parameters are taken care by giving a good environment. Latest thing, of course I know that because there are a lot of people have a phobia of getting into a MRI. Now the standing MRI has also come in, but we have promoted at that time, utilize the technology, use the home theater. Wall has a projection of, the sea beach. A fellow is lying in a Goa beach, as though that kind of an environment is created, he is just left out. Just now, in prior to this, you have seen a wonderful daylight ceiling is also being done by GE or Siemens. Now these are the kind of environment which relieves stress. Then pediatric ward where you can have these kind of a feel. Hand wash station, even the using of right material like wall finishes in lab, we have used the coherent, and there are plenty of antibacterial issues are there, but at the same time, like in the previous speaker he has explained, which can take the abuse of stretcher or trolley, the materials are there. Then the particular area where there is a possibility, you can always add on the resistive material. Environmental comfort, now here I would like to just sensitize you. Indoor air quality is one of the key issue with well designed ventilation system and air filters to prevent nosocomial infection. Doctors, clinicians are generally not much aware about the total indoor quality parameter. The healthcare engineers, particularly the HVAC engineers, are also very few who are tuned to this. Problem is, you think the right kind of air is coming or not is not known. I'll show you in the coming slide. And choosing the right material and specification, scrupulous hand washing can substantially lower infection areas in hospitals. Right layout and detailing reduce patient fall, which often occurs when a patient tries to reach the bathroom at night disoriented. Reduce noise. Then staff finds it better job satisfaction if the staff is focused and given the best this thing, and even the good sleep. The very good wayfinding system and signages helps in reducing stress. Design staff focused hospital, so that I just explained to you, well lit nursing station reduce medication error and stress. Indoor air quality generally has particulate gases and microbial. Photohydroionization, what is it? We put filtration, we trap the pathogen. It is colony of pathogen in that filter, we don't kill them. That is where the problem comes. Photohydroionization is a hydrogen-based oxidizers are created by exposing activated oxygen molecules to a hydrated catalyst containing 4 unique metals, that is 3 nm UV light photon energy. Friendly oxidizers are hydroperoxide, hydroxide, superoxide ion and ozonide ion. This is how it looks like. You can put it in your AC duct. You can see this is where how it kills. Friendly oxidizers are blown in the conditioned space, microbes and gases are destroyed on contact, oxidizers break down into oxygen and water vapor. This is how these things are floating, and you will find the air which kills the airborne and surface pollutant when it is crosses and passes through this, and when it is going back through the filter, even it clears the whatever is stuck in the filtration. Then we have the more important thing is ultraviolet germicidal irradiation and filtration are the key. flexible and can be installed in any new or existing HVAC. Second is, you have already heard about HEPA filter. What is HEPA MD? HEPA MD is high efficiency particulate arrestance microbial destruction. It is not only arrestance but it destructs. And it has a 4 parameter: exposition to non-thermal plasma, then captured by electrical media, then molecular filtration and molecular trapping. And this is how the HEPA MD technology works, in which how it destructs the airborne pathogens and keeps you a safer air. Now you have the product range in the form of, it is like a cupboard, it can be kept, you don't have to change your air conditioning system, it takes care of your indoor air quality. It can be put in a ceiling. This is the one which, if there is a burn patient or highly infectious patient, you can cordon off. Within that you can maintain the kind of air quality you require. And the last one is, when you are designing something new, you can take care. Using of indoor, earth tunnel cooling system in a general area is one of the important things, and flash misting can be added. Then using of variable air volume, so that energy efficiency, you are not wasting your air conditioning all throughout. Enthalpy control is, when you have a temperature outside is much lower, your compressor is not just starting, it can just carry on with the available this thing. And this is how the VAV system works, that whichever area we want to control, where the occupancy is not there, it shuts off. Where the occupancy is more, it automatically picks up the air volume of other area and gives you a comfort level. The important is cooling coils and humidification system are the one where pathogens are breeding. So you have to be careful on that, and inefficient cooling coil will be the cause of infection. Now the airborne contagion opening window, you have seen that during SARS when it attacked, cross ventilated wards never had problem. The centrally air conditioned or this thing was having a problem. So opening window and doors provides wonderful cross ventilation. Environmental friendly green hospital, use of non-conventional energy, waste management, excellent features that result environment protection, water conservation, harvesting, usage of eco-friendly recycled products, building management system to monitor and air control, and barrier-free environment are the need of the hour, and healing architecture I just spoke about. This is how you can use grass paver, solar thermal or carbon oxide sensors, or efficient lighting, state-of-the-art HVAC and low volatile organic compound material as your finishing material, and use the recycled water for flushing, irrigation or cooling tower. 5 areas in which hospital have take action according to the JCA report: economic viability, adoption of technology, patient-centered care, staffing and hospital design. So economically, hospital will be expected to increase efficiency, reduce cost. Among other things, technologically hospital will have to make changes that can reduce the workload while at the same time being easily integrated. Mandatory requirement, I had told you, we have to have a ECBC, that is Energy Conservation Code, and 3-star Graha rating is a compulsory now. That is green rating of integrated habitat assessment. As you have a LEED certification in the foreign countries, we have the Graha rating. I just in a conclusion, I will be demonstrating one ART center, that is antiretroviral therapy, where we have just demonstrated how the ventilation makes a lot of difference. AIDS patient, this is the first level of treatment, and if he is a neighborhood, some TB patient is sitting and if he coughs, he had it. So that is why we are trying to show. Here he comes for doctor consultant's room or a nursing or counseling area. Generally comes, registers, waits, meets the doctor and go away. Here what we do, we throw the air from here and it goes out. It's unidirectional or uniflow. So that this is the consultant room. Consultant will sit here so that the air is from his behind and it is passing further. The infection is not even to the a person who is using it. And similarly, the one who is registering or giving a pharmacy or the drugs, the airflow is from his room to outward, so that the patient who is standing, if he is an infected patient also, is not bothering the other person. And each area you will find the fans which have been forcibly kept so that it is all pushed out. And you may be wondering, in the previous slide, Split type air conditioners are never recommended for any air conditioning. Here it is only doing a temperature control because air is pushed from one side and it is pushed out from the other side. And even the door has a small cut so that the airflow is maintained as we used to maintain the ventilating system. One more very important thing in the room design of a ward I am trying to show is this is a very common which every ward we do. What we do is we control the airborne infection by pressurization. Rooms are like a hospital or hotel room, but the problem is the moment a patient gets into the room, he says switch off the air conditioner, I am feeling cold. The whole system works differently. Here what we do, we try to maintain a positive pressure in the corridor, negative in this lobby where the cupboard and other facilities are there, and more negative in the toilet, and the highest negative level is in the shaft. Rooms are in positive pressure. Even if I open the window, some of the season I can open the window and take a fresh air, it will remain the positive pressure because this being a barrier, and it is not allowing the infection from here to the visitor or the paramedic staff, and it is not passing on this infection to that area. So this is one area. Even sometime the opening of the shaft is kept on the corridor, the pressure is positive to negative, nothing will come out of the shaft here. Also sometime you must have seen the plumber is working inside the toilet and the patient wants to use toilet, it becomes a problem. So the maintenance also can be attended from outside. And lastly, the antibiotics are not the cure for superbug, cleanliness is, and hospital needs to be kept clean. Accountability is needed, not money. Run a hospital like a fast food joint, clean as you go, and it's all staff's responsibility. Last, I just want to sensitize safety factor. You have got a code for a safe hospital. Structurally it is safe because of compulsory. Non-structural member, false ceiling, ducts, and now we are working the guidelines on NDMA, that is National Disaster Management Authority. You make all structural glazing, 10 centimeter shift, and imagine what happens. Whether now we are getting in touch with the glass manufacturer, they themselves are not too sure about all the safety parameters. So these guidelines are very important. All patient has the right to ask, am I safe in the hospital? Small thing, engineering services should not collapse. At the time we know that Bhuj earthquake, this is what happens when the entire, one earthquake and the whole thing, you can see the whole medicine, gas cylinder or even the cooling tower can shift. Small clamp can prevent, small hook can prevent fall of medicine, and evacuation plan of every hospital is must. Blending of open spaces, fire escape staircase, don't forget every incident was very recent. Refuge area for easy evacuation of multi-story structure, appropriate signages, and this is how we do it in one of the hospital in Lady Harding. We have a solarium or a day space which can also act as a refuge area in terms of evacuation. So we require, a patient wants a built environment that promotes connection to staff, is conducive to well-being, is convenient and accessible, is confidential and private, shows caring for family, is considerate of impairment, facilities connect to the outside world, and it is safe and secure, easy wayfinding. The built environment enhances patient flow, overall efficiency and function operation of the other health facility. Thank you very much, and this is my email ID. So anyone who wishes to be in touch with me for any reason, he can be always in touch with me. Thank you very much.